Okay, so today we're going to talk about something you probably never ever think about, compressed air. But for modern manufacturing, it's basically the lifeblood. We're going to break down a really fascinating case study from a food plant over in Malaysia, and you're going to see how a little bit of smart tech uncovered a massive, hidden source of wasted energy, and, of course, a huge opportunity for savings.
And look, this is not some small niche problem. Industrial compressed air systems are famous for being energy hogs. In factories all over the world right now, they're running super inefficiently, just hemorrhaging electricity and cash, all for something as simple as air.
So what does that inefficiency actually look like in the real world? Well, check out the left side of this diagram. See that wavy line? That's the system's air pressure before they installed the fix. It's just all over the place. It's like driving your car by just slamming on the gas and then slamming on the brakes, over and over again. It's chaotic, it's wasteful, and it puts so much unnecessary stress on all the equipment.
All right, so to really get why this is such a big deal, we've got to zoom in on this one core idea, the problem with pressure.
Okay, this is where the math gets kind of scary, but also super simple. There's this rule of thumb in the industry, and this report proves it's true. For every single bar of pressure you generate above what you actually need, your energy consumption jumps by a staggering 7%. Just think about that. 7% more energy for pressure you don't even need. That adds up so fast.
So you're probably asking, why was it so unstable in the first place? Well, in the old system, you had all these powerful compressors, but they weren't talking to each other at all. Imagine an orchestra where every musician is just playing as loud as they want, whenever they want. Total chaos, right? That's what was happening here. They were competing, not cooperating.
And that, right there, leads us to the solution. They figured it was time to give this chaotic system, well, a brain. And this is it, the ACC-E8 Central Control Unit. You can think of it as the conductor finally showing up to rehearsal. Its job is actually pretty simple, but it's genius. It watches the system's pressure constantly, and it intelligently decides which compressor needs to run, which one can take a break, and exactly how hard each one needs to work. It's the brain that finally gets the whole orchestra playing together.
And we're not talking about a little string quartet here. These are the instruments that New Brain is controlling. We're talking about a bunch of heavy-duty industrial air compressors. Before, they were just solo acts doing their own thing. Now they're a finely tuned team. Okay. So let's see what actually happened when the conductor finally picked up the baton. All right, so the theory is all well and good, but what happened when they actually flipped the switch? Let's get into the impact of all this control. You know, what's wild is how quickly this all happened. The team started installing and testing everything on March 2nd. Literally 2 days later, it was fully automated, running the whole show, and by the 13th, not even 2 weeks later, they had enough data for the report we're digging into today. And this is the aha moment. This is the real data. On the left, that's the pressure from March 3rd. You can see it. It's all choppy and wild. But then, look what happens on the right side of that red line after the system took over. It is dead flat, rock solid. The change wasn't slow, it was instant. It was incredible.
I mean, that's the whole ball game right there. They went from total, wasteful chaos to this beautiful, rock-solid stability. The system was finally delivering exactly the pressure they needed. No more, no less. But wait, the story actually gets even more interesting.
See, because once they had all this clean, stable data to look at, they found something. Something nobody expected. Something even the guys running the factory for years had no idea about. All of a sudden, the data itself started asking a really awkward question. For years, the story was that the factory needed a very specific amount of pressure to run properly. But what if the factory had been asking for way too much pressure this entire time? This is so cool. Here's the clue they found hiding in plain sight. The factory guys said, we absolutely need a minimum of 6.8 bar of pressure. Can't go below that. But when the engineers looked at the old data from before the fix, they saw that sometimes the pressure had dipped all the way down to 6.2 bar. And here's the kicker. Nobody ever complained. Not once. The production line just kept humming along. It meant that their minimum required pressure wasn't a requirement at all. It was just a habit. And that really gets to the core of it, doesn't it? As the report says, providing overqualified compressed air, that's just a fancy way of saying more pressure than you need, is just wasted energy. Remember that 7% penalty for every extra bar of pressure? This factory might have been paying that penalty for years, for literally no reason. So,
This discovery didn't just save money, it created a whole new mindset, all based on one powerful idea: the measurement mandate.
So the report laid out 3 really clear next steps. Step 1, review. Okay, now that we know we don't need so much pressure, let's test it. Let's find out what the real minimum is and save even more money. Step 2, improve. Move the main sensor to a better spot so the data is always accurate. And step 3, measure. Put in a flow meter to see not just the pressure, but how much air is actually being used. That gives you the full energy picture.
You know, at the end of the day, this isn't really a story about compressed air. This could be about anything. A company's marketing budget, a city's traffic patterns, you name it. The lesson here is so much bigger. It's about what happens when you shine the light of data on any system. You don't just improve it, you start to truly understand it and question the old rules that maybe weren't rules at all.
So, I want to leave you with this one quote from the report's conclusion, because it just says it all perfectly. You can never manage anything without measurement. It's so simple and so true. It just makes you wonder, right? What are the hidden costs, the wasted energy in our own systems that we could find if only we just started measuring?